Hello learners, we are back in the last session of book 1 and we are dealing with the chapter Differential Equations and Applications. मैं हूं आपकी मैथमेटिक्स गुरु शिवानी मैम and today I'm going to explain you people how this differential equation is formed, what are the various characteristics like the order and the degree of the equation, how to solve a differential equation and how differential equation is applied in the day-to-day life applications. Again, one of the most important chapter of book 1 and one of the most important chapter of grade 12th altogether, be it like a commerce stream or science stream or art stream, this is a very, very important chapter. So let's start with the thing that what exactly is a differential equation and how we are going to apply that. Even though the name suggests differential, it is again an application of integration. We'll be using a combination of both differentiation and integration to come to the answer over here. So let's first see that exactly what is a differential equation. So we are dealing with an ordinary differential equation. Now a differential equation in which the dependent variable, now anything can be the dependent variable, let's say y, depends only on one independent variable, then it is called an ordinary differential equation. Now when we have a differential equation, it is usually having an order and the degree, and the order of this is the highest order derivative occurring in the differential equation. So differential equation, when you see, it is written in the differentiation form. That's why the name is differentiation, but it is solved using integration. That's how integration comes in picture. So dy by dx plus y is equal to x. Let's say this. Now the highest order derivative over here is 1, dy by dx. So the order is 1. Say if it is x square d2y by dx square plus x dy by dx plus y, then you can see that highest order derivative is d2y by dx square, which is order 2. Third, if it is dealing with d3, then it will be order 3. Now the next thing which comes is degree of the differential equation. Now degree is the power of the highest order derivative when all the derivatives are made free from fractional indices and negative sign in case if it is there. So in this case, when we talk about this, let's say this example, x square d2y by dx square to the power 1 plus x dy by dx plus y. So here the order is 2 because the highest thing is d2y by dx square, and since the power of the order is 1, the degree becomes 1. So this question usually comes for 1 mark in MCQ. Always you'll be seeing that 1 mark MCQ, or in the true false sort of question, you'll be getting a question on the order and degree of differential equation. Now the second thing is there, how to solve a basic differential equation. Now any function y is equal to fx plus c which satisfy the differential equation is basically the solution of that. And to come to the solution, we have to go to the antiderivative, which is integration. So a solution of a differential equation in which the number of arbitrary constant is equal to the order of differential equation is usually the general solution. And for a particular solution when we deal with, so in this case, actually, you can see that the solution which can be obtained from the general solution by giving fixed values. Because we all know when we calculate integration, we always write one constant of integration c. So when c is there in the equation, we call it as general. But if we are putting the fixed value of x and y to calculate the value of c, it becomes the particular solution over there. So here again, I'm just showing 1 or 2 solved examples so that you can get an idea. Now, depending upon the number of arbitrary constant in the equation, we decide what should be the order of the differential equation. So if we are having one arbitrary constant, then dy by dx will be the case, that is your order 1. If we are having two arbitrary constant, then we'll go to the next level also, calculating d2y by dx square to get the answer. So let's say one function is there, y is equal to a e to the power x plus b e to the power minus 2x. Now you can see there are two arbitrary constant a and b. E to the power x and e to the power minus x are the variables. So first we'll differentiate normally with respect to x, dy by dx is this, and then we'll differentiate one more time to come to the final answer. Now you can write the answer, or it means basically you have to write the answer without those arbitrary constants. So this is how where you have to actually think and calculate and work. So when you see that d2y by dx square is a to the power ex plus 4b to e to the power ex, then you can see a combination between them, find a relationship and see this is actually 2 times of y, and we can give a relationship like this. So this is how we solve. Sometimes we can directly lead to the answer, easily remove the arbitrary constant. Sometimes it takes time. See, analysis is required to remove the arbitrary constant. So this is how we can form the general equation. Now some examples are there, like y is equal to e to the power x. So dy by dx is directly e to the power x, which is y. So this will become your equation. Now if y is 1 minus log x, then x square d2y by dx square is 1. Again, if y is a e to the power x plus b e to the power minus x, again you can go to the d2y by dx square, it is y. And if it's a fixed value like ax square plus by square is 5, then the general equation will come as xy d2y by dx square plus x dy by dx whole square is equal to y dy by dx. Now in the questions, you can't apply them directly. You have to solve and get the answer. They are just there as a hint, so that if you get a direct question in MCQs or one mark question, then you can apply it directly. Otherwise, questions need to be solved only. So now we'll see some question how to solve the differential equation and come to the answers. Okay, now we'll start with the questions. The first one is from exercise 8.1, which is dealing with the order and degree. So here I can show you directly here. Now in this question, when you see this question over here, the value over here is d2x by dt square dx by dt whole square plus 8. Now as I said, order is the highest value till which you are actually differentiating. So order becomes 2 over here. So here you can easily get that the order of this equation is 2. And what is the power of this value? Forget about the power of dx by dt or something else. The first power, which is the order's power, will be your degree. So degree becomes 1. So sometimes kids will see, okay, 2 dikh raha hai, this is the highest degree. No, but you have to go with the degree, or you can say the highest power of the order thing. Now let's see one more question over here, which is dealing with this particular part, under root this. So why I'm taking this? Because first you have to simplify this to a proper term, so that the dy by dx is not there in the denominator और आपका यहाँ पे fractions नहीं रहे. So this square root means that it has the power 1 by 2. So what will we do? That will take this as the power 1 by 2, square both the sides. So when we square both the sides, this thing will get nullified, the power will get nullified, and then we'll come across 1 plus 1 by dy by dx whole square is equal to dy by dx to the power of 3. Now still it is not done, because 1 dy by dx is having the negative power. So we'll multiply the whole thing with dy by dx whole square. So ultimately you will come across dy by dx to the power of 2 plus 1 is equal to, now this will become dy by dx to the power of 5. So here we can say the order has become 1 only, because that's the highest thing. And then degree now is 5. So this is how we calculate and come to the order and degree. The second part of this particular thing is going to exercise 8.2, where we are going to see the questions based on solving or forming one differential equation. So now we are having exercise 8.2, where we are using the formation of differential equation. Okay, so here let's take the first question, which is dealing with y is equal to a e to the power 3x plus b e to the power minus 3x. Now first we'll calculate the number of arbitrary constants. We know here that we are getting two arbitrary constants, a and b. So we have to go to second order derivative. So dy by dx is 3a e to the power 3x minus 3b e to the power minus 3x. But we have to go one more time. So we'll write d2y by dx square is equal to, now it is 9a e to the power 3x minus, or again plus, basically minus minus, so 9b e to the power minus 3x. So ultimately what you are going to get is d2y by dx square is equal to 9. Then in the bracket you can write a e to the power 3x plus b e to the power minus 3x. Because what we have to do is we have to remove those arbitrary constants from the equation. So this thing is actually y. So your final answer will be, by replacing this as y, d2y by dx square is 9y. So in this manner we complete the equation formation, differential equation formation of a question. We can take one more question over here. Say this is second one. Now main question second, x square plus y square is equal to 2ax. Now if you notice, 2 is a constant over here. 2 को हम arbitrary constant नहीं लेंगे. Arbitrary is the one जिसकी value change हो सकती है. So here the arbitrary constant is only a. So since there is just one arbitrary constant, what are we going to do? Differentiate it just once. So differentiating with respect to x, what are we getting? 2x plus 2y dy by dx is equal to 2a. Now this a, or you can say this 2a, has to be replaced. How will we replace? We'll use the first equation. Now in the first equation, 2a can be written as, so this is 2x dy by dx, and instead of 2a we are going to write x square plus y square divided by x. Just by switching this x over there, we are getting the value. Multiply the whole equation by x. This value is y. Sorry, I've written it as x. Okay, it is 2y. So now it is 2x square plus 2xy dy by dx is equal to x square plus y square. We'll simplify this. So this is x square, because 2x square minus x square, minus y square plus 2xy dy by dx is 0. This will become your final equation. So this is how we can calculate or formulate the differential equation. Now after this, the next thing comes as solution of a differential equation. So we'll deal in detail how differential equations can be solved, because it depends upon the form of the equation that which formula or in which way we are going to go ahead with the question. The first method to solve the differential equation is variable separable method. So in this one, we are going to separate the variables to the two sides and integrate the things accordingly. One of the easiest method, you don't have to be actually very much thinking about the things, like let's see, dy by dx is 1 plus y by 1 by x. So very clearly we can separate this y, we can shift it towards the left hand side as denominator, and this dx can go towards the right hand side as numerator. So we will be left with dy upon 1 plus y is equal to dx upon 1 plus x. So then this is the integrating form or integrable form. So we'll integrate both the sides, put the integration mark, get the answer. This is log 1 plus y is equal to log 1 plus x plus c. Now, when each and every term of the question is there in log, then assume your variable also as that the constant of integration also as log c. So then you can easily remove them. So log 1 plus y minus log 1 plus x, log ka basic rule hai ye, quotient rule, log m minus log n is equal to log m upon n. So we'll put them as log 1 plus x upon 1, y upon 1 plus x is equal to log c. And then by anti-log, we can remove the value of log and your final answer will come up as 1 plus y upon 1 plus x is equal to c. Now this is the general solution. So in this way we can come to the answer which is free from the log, dy, dx, everything, and the final answer is there. And for this value, if they wanted a particular solution, they would have given you the value of y and x to come to the value of c. So that is one way to solve the differential equation. The second one is when we cannot or we are not able to separate the variables clearly. So in that case, we'll take the help of the method of substitution. Method of substitution is very common in this chapter. We are using it on and off for this particular thing. So here also we are going to go with the method of substitution. So let's say this is the first equation, 2x minus 2y plus 3 dx is x minus y plus 1 dx. And we need the particular solution at x is equal to 0 and y is equal to 1. So you can see that how much we'll try, we cannot differentiate or separate x and y. But we can see that in 2x minus 2y, if we take 2 common, we are left with x minus y. So this is what will be our substitution base, because that is going to be common in both of them. So we'll assume x minus y as t, we'll calculate dt by dx, which is 1 minus dy by dx, and substitute everything accordingly. So dy by dx will be substituted as 1 minus dt by dx. This part will become 2t plus 3 by t plus 1. Shift this one thing and then solve to come to the answer. Once you solve this, now you are left with dt by dx is minus t minus 2 upon t plus 1, and switch the t's to one side and dx or the x variable to the other side. In this manner, usually आपके x के पास केवल constants बचते हैं. Okay, variables पूरा का पूरा t के साथ जाएगा. When we integrate this, then we can calculate integration method. I'm sure you must be knowing how to integrate. But when we are doing the questions over here, I'll show you also how to go with the thing, because it's a quick revision for the integration chapter also. So when we integrate this, after the integration, we are left with x minus y minus log this is equal to minus x plus c. Now here if you notice, c is just taken as c. We are not taking c as log c because each and every term is not log. So then we'll just take that as c, and since we want the particular solution, put the value of x and y which is given over there and calculate c and then write the particular solution. So this is how we can calculate the another kind of differential equations also when we are not able to separate the variables clearly. Now the third kind. One more thing, with practice it will come that you have to judge that which kind it is. The third kind is homogeneous differential equation. Now homogeneous differential equation basically is a differential equation of the form fxy dx plus gxy dy is equal to 0. So it means जितने भी terms होंगे वहां पे ना, उनका power हमेशा same होना चाहिए. Okay, or you can say degree of each term, like x cube dx plus y cube dy is a homogeneous equation because x cube and y cube both are having the same degree 3. यहाँ पे what I am talking about degree is actually the degree of algebraic expression, not the degree of the differential equation. Here again x square y dx is plus 8y cube dy. So x square y degree will become 2 plus 1 3. Y cube degree is 3. So it is a homogeneous differential equation. Now let's see how this homogeneous differential equation can be solved. So the method to solve the homogeneous differential equation is we'll use one assumption. So there is a fixed assumption over here. You don't have to actually worry about that. Y is equal to tx. In some books they also use vx. Anything can be used. Variable should be there. And then we differentiate this particular thing. So first one will be there dy by dx and t d by dx of x, which is 1, plus x dt by dx. This differentiation has to happen using the formula uv. Once you have this one, then in the main question, substitute all the y's as tx and then substitute dy by dx as dt by dx. At the end, solve it using t and x, and ultimately you will be able to get the equation, final equation, and then resubstitute the value of t, and then you will be able to get the final value. So this is how we'll be solving this kind of differential equation, which is known as homogeneous differential equation. So now let's do some questions from the exercise to make your concept better. Now let's take exercise 8.3 to solve the differential equation. Now when we take the first question, you can see that for the first question, dy by dx is equal to x square y plus y. I have written the question over here for your better understanding. Now here we can take y common and write it as x square plus 1, and this is dy by dx. So in this one you can see the variables can be easily separated. आप dy के साथ नीचे y ला दो और x dx will get shifted over here as x square plus 1 dx. Now once you come to this, we'll come to the integration part. So after you get this, write the statement integrating both the sides. We come to this part. Integration of 1 by y is log y. Put the y thing in the modulus sign. And here is a simple integration like x cube by 3 plus x and plus c. Now this answer will be treated as your final answer of that differential equation. Now we'll take one more where we cannot actually separate the variable. So then in that case we have to see कि exactly किस तरीके से हम उसे convert करें. What can be the t for that? So let's take the last question. Second का ये last sub part है, fourth sub part. dy by dx is equal to 4x plus y plus 1. Here they want a particular solution. They have given the value of y and 0, which we'll take into consideration at the end. So when we solve this, we can see that I can't switch y without the intervention of x. So the variables are not separable. So we'll take one assumption. Let t is equal to 4x plus y plus 1. Differentiate this t. So dt by dx, we are differentiating with respect to x, is 4 plus dy by dx. 1 will become 0. And then dt by dx minus 4 becomes dy by dx. Now we'll take this value into the main equation. When we switch it, what are we getting? We are getting over here, instead of dy by dx, we'll write dt by dx minus 4. And here we'll write t. So we can switch dt by dx becomes t plus 4. Now this is the format in which variables can be separated. So we'll separate the variables. Dt upon t by 4, t plus 4 is equal to dx. Then integrate both the sides. You are left with log t plus 4 is equal to x plus c. Now this is the general solution, but we can't give the general solution in t terms. So we have to resubstitute. So therefore the answer, the general solution is log. Instead of t, we are going to write 4x plus y plus 1 plus 4 is automatically there is equal to x plus c. So we are going to get log 4x plus y plus 5 is equal to x plus c. Now once you get this value, now we'll come to the particular solution. So for particular solution, we are going to write when y is equal to 1 and x is equal to 0. So let's put the values over here. Log x is 0, so ye 0 aa raha hai, y is 1 plus 5 is equal to 0 plus c. So we'll get the value of c as log 6. And to get the final answer, what you have to do is that in this general equation, आप c की value को substitute कर दोगे. So when we are coming to that thing, I'm rubbing this first part to write your final answer here. So it will come as log 4x plus y plus 5 is equal to x plus log 6. Since there are two log terms, we'll simplify it by shifting it to one side. And when we shift it as minus, हमें log m by n का concept मिल जाएगा, which is this upon 6, which is equal to x. And this becomes your particular solution of the question. So in this manner, we'll solve the one where we cannot easily separate the variable. Now let's see one question of homogeneous equation also, homogeneous differential. I have just discussed the homogeneous differential equation with you people. So here when we are going with, for homogeneous equation, we are coming to the next exercise, which is exercise 8.4. So in exercise 8.4, majorly all the questions are of homogeneous, but it's not that everything. Sometimes you can do it just by simply separating the variables also, like your first question. But some of the questions are definitely the ones where we have to apply the homogeneous thing. So let's take one question over here. Let's take the question number 3. So in this question, we can see that the question states x square y dx minus x cube plus y cube dy is equal to 0. Now, how come is this homogeneous? You can just see that every term has the degree 3. First term also, second term also, third term also. So we can easily pass it as homogeneous equation. Now, first simplify it in the form of dy by dx so that we can start our work. So for that, we'll substitute this to the other side. X square y dx is equal to x cube plus y cube dy. Don't open the bracket right now. Keep it in the bracket. And then you can see x square y upon x cube plus y cube is equal to dy by dx. Now we can't separate anything and it is a homogeneous one. So हमारा एक ही यहाँ पे assumption होता है, that is y is equal to tx, or you can say t is equal to y upon x. So let y is equal to tx. Now when you differentiate with respect to x, so here what will we get? dy by dx is equal to, क्योंकि यहाँ पे uv formula apply होगा. So dy by dx is t, dx by dx is 1 plus x dt by dx. So once you come to this stage, this whole thing will be replaced over here. So let's mark this one. So then we'll say from 1, what when we get? Instead of dy by dx, let's put this whole thing. So I'm writing this towards the left hand side for the sake of doing the question in the proper manner. Now, x dt by dx is equal to this whole part. Now, every y will be converted to tx. Here also x cube and y cube will become t cube x cube. So once we write the things in the form of t, then y should not be seen in the question. Once we've come to this stage, अब इसे भी थोड़ा सा simplify करेंगे to come to the answer. So for that, I'm using shifting of the word t to this. So x dt by dx, ये variable आपका shift होगा यहाँ पे. Before shifting, I can take x cube common over here. तो यहाँ पे t बच रहा है, नीचे भी x cube common है, we are left with 1 plus t cube, and this t has also shifted. Now x cube got cancelled. We'll solve this part. यहाँ पे simply हम एक step को just mathematically करते जा रहे हैं. So now x dt by dx is equal to t. अब ये हम लोग as LCM ले लेंगे, तो the upper value will become t multiplied by 1 plus t cube. Okay, so this will be there when you open t minus t cube upon 1 plus t cube, and here we are left with x dt by dx. So you can see now that we are having majorly the variable t and very few x, only one term of x is there, so it becomes easier for us to separate the variable. Now let's separate the variable here. This t is getting cancelled. dt, so this will come towards dt, which is 1 plus t cube upon, this will become t to the power 4, one thing here. So we are dealing with now, because t into that, so upon t to the power 4, and here minus dt by dx. माइनस क्यों आ रहा है? क्योंकि ये जब टर्म चेंज हो रहा था तो यहाँ पे ये माइनस चेंज हुआ है because of the sign outside. So I'm not shifting that minus over there because with minus we will be able to put it over the side where the values are less. It becomes easier if the variables are less over there. So now when we come to this final thing, this thing is now 1 upon x dx, which is with minus. Let's solve this. Integrate both the sides. So once we start integrating, इसको हम दो parts में divide कर देंगे because denominator एक ही है हमारे पास. So this t cube by t to the power 4 dt, and this side will be simply minus integral 1 by x dx. Now let's start integrating. तो ये पार्ट है आपका t to the power minus 4, it will become t to the power minus 4 plus 1 upon minus 4 plus 1. यहाँ पे ये cube and 4 जाएगा, तो 1 by t will be the case, which will become plus log t. Here it is minus log x plus c. But ये आपका final answer नहीं है. So this is going to be a long question because now we have to substitute the value of t as y by x. So once we come to this stage, now we are going to resubstitute the value of t. So let's start from the last stage जो हमारे पास बची हुई है. Here it comes as t to the power of minus 3 upon minus 3 plus log t plus log x, I shifted it over here, is equal to c. Now when we resubstitute the value of t, it becomes minus 1 over 3, minus 3 है यहाँ पे, t is y by x. Because y is equal to xt, so t is y by x to the power of minus 3 plus log, again y by x plus log x is equal to c. थोड़ा सा और solve करेंगे so that we can come to a decent answer. So since the power is minus 3, what will we do? We'll switch it to make the power positive. Once we get this, this log y will get converted to log y minus log x we have plus log x, which will get nullified, and then c. So finally, we are coming across as a term which is coming, or which is basically, see, you can write this here, that minus 1 by 3 x cube by y cube plus log y is equal to c. So you can leave the answer over here. This is the general solution because they are not asking for the particular solution. So ये आप इस level पे answer छोड़ सकते हो. आप इस c को log c assume करके भी कर सकते हो. So then your y and c will come to one side, and then you can get yc is equal to this value also. Both the things are acceptable by any of the board. Now let's see the next kind of differential equations, which are the next level of solving the differential equation. See, the next thing is linear differential equation. Linear we all know is in the format of y is equal to mx plus c. तो यहाँ पे भी थोड़ा सा format वही है. The general format can be dy by dx plus py is equal to q. So we can see the general format over here, that dy by dx plus py is q, where p and q are the functions of x or constants. Make sure. So for this solution of this, इस एक और equation, इसका एक और format भी होता है, that is the dx by dy plus px is equal to q. We'll see that also, but most of the questions will be of this format. So the solution of the linear differential equation requires one thing known as integrating factor. First time ये terminology use हो रही है इस particular chapter में. तो first we'll find out the integrating factor. Integrating factor actually is the value which we calculate by e to the power of integral p dx. Once you calculate this integrating factor, then the solution can be directly written and then we do the solving. So the solution for this equation becomes x into integrating factor, integral q dot if, which is integrating factor dy plus c. So integrating factor we have already seen will be there. Once you get this integrating factor and the final answer will be there, you can easily substitute or solve the given equation at the end. Two formats, again एक बार और मैं वापस बता दे रही हूँ. जब आपका y का फॉर्मेट है that dy by dx है, तो आपका आएगा y into integrating factor is equal to q dot if dx plus c, and same thing अगर आपका dx by dy फॉर्मेट है, everything else is same, only x if and यहाँ पे dy, and we'll be able to get the things. Definitely integrating factor दोनों का change हो जाएगा. So let's take one example and then I can show it with the proper question. Say dy by dx is x plus y, one of the simplest question. Write it in the format of dy by dx plus py is equal to q. So when we write it in that format, यहाँ पे p becomes minus 1, q becomes x. Now we've seen that p and q can be in the form of the dependent variable, independent variable or constants. So यहाँ पे आपको मिल गया p as minus 1. So integrating factor becomes e to the power minus 1 dx, which is e to the power minus 1. Then put directly into the solution that y e to the power minus x is equal to integral x e to the power minus x dx plus c. And then what we have to do is that we just calculate the integration of this part, क्योंकि left hand side तो already आपके पास solved format में है. तो when we calculate, यहाँ पे हम use करेंगे UV rule, that is integration by parts. So we'll come across x e to the power minus x by minus 1 minus integral of e to the power minus x by minus 1 dx by dx, and then final answer will be given x plus y plus 1 is equal to cx, or in the format of this, which is plus c. So this is how linear differential equation will be solved. Then the last part of this chapter is dealing with the practical applications of this. So the practical applications happen in case of, say, population growth, growth in the bacteria, or you can say where the growth rate is mentioned to you. So questions are generally like, if the population is increasing at the time t, then the rate of change is proportional to the population present at that time. So if dp by dt is directly proportional to p, we'll be able to solve the final thing using a constant kp, integrate both the sides. We'll get one more constant over there. So we'll get log p as kt plus c, or p is equal to e to the power kt plus c. So with the given values, we can calculate the value of c, we can calculate the value of k and solve the desired question. So to understand this more, now let's do the exercise which is there at the end of the chapter. So let's do one question of the linear differential equation. Let's take the question number 3 from exercise 8.5. So when we do the first part of the third one, it is x dy by dx plus 2y is equal to x square log x. Now why have I chosen this question? क्योंकि इसमें already आपको question given format में नहीं है. You have to come to the format over here. So how will we do this? Divide everything by x. So we'll get dy by dx plus 2 by xy is equal to x log x. Now this is of the format dy by dx plus py is equal to q. यहाँ पे हम एक statement लिख सकते हैं on comparing with the differential linear equation. So when we compare, p is equal to 2 by x and q is equal to x log x. So first step for this particular question is to find the integrating factor. Let's calculate that. So if is actually e to the power of integral 2 by x dx. So 2 by x dx will actually be formed as integral. आप 2 बाहर भी ले सकते हो और इसको 2 into 1 by x dx लिख दोगे. So this will become e to the power of 2 log x. यहाँ पे जब आप इंटीग्रल ले रहे हो, don't bother about c. We don't have to write c over there. We'll just calculate. This can be simplified as log x square, and e to the power log of any term is that term itself. ये मैंने पहले भी आपको कराया था. So then we can directly come to the answer as x square. So your integrating factor over here is x square. Now if you see, अभी जब मैंने आपको फॉर्मेट बताया था कि जब आपका आंसर आ रहा है तो what we have to do, तो actually if the question is of the format dy by dx is equal to plus py is equal to q, then the final solution to this will be, I'm not changing the screen, first just rub कर रही हूँ so that you can see the question all the time. So here it will become y integrating factor. So what is your y over here? Y is the various value y, integrating factor was x square. So यहाँ पे आप heading लिखना, therefore the solution of the equation is of the linear differential equation or given differential equation. Okay, so y x square is equal to integral q. Now q over here was x log x. So x log x multiplied by integrating factor which was x square dx plus c. So now we'll be solving this. इस पार्ट को हमें कुछ चेंज नहीं करना है. y x square, this will become x cube log x dx. And now we know what to do over here because it is uv. Okay, so we have to do it by integration by parts. When we are doing integration by parts, log has to be given preference. So it is log x integral of x cube dx minus integral of d by dx of x d by dx of log x. This is the d by dx of u thing is there into integral of x cube dx और एक final dx. Okay, so this is how we will be writing this part. I'm just putting this thing here and this. Okay, that's how we write this. Plus c will definitely continue. So this is now x to the power 4 by 4 log x, and this thing is equal to y x square. You can put a therefore, or this implies sign in the starting, minus, now d by dx of log x is 1 by x. So this is 1 by x into x to the power 4 by 4 dx plus c. So final answer will become yx square is equal to x to the power 4 by 4 log x minus, now x to the power 4 divided by x will become x cube. So x cube का integral होता है आपका x to the power of 4 upon 4, तो ये 4 multiplied by 4 is 16 and c. So this thing will become your final answer for the differential equation in the linear format. So once we get this, अगर क्वेश्चन आपका dx by dy पे है, जो कि हो सकता है किसी एक क्वेश्चन में हो सकता है, so then the only thing is कि आप same thing opposite कर दोगे to solve the answer. They can use another variables also, like we have dr by d theta also. Same manner में आप solve करोगे, just changing the variable y and x placement. Now let's do one question which is dealing with the applications of differential equation. Now the questions of applications are there in exercise 8.3. पहला क्वेश्चन मैं ले रही हूं आपको एक population growth question. Say this is the question number 4th of the exercise. So find the population of a city at any time t, given that the rate of increase of population is proportional to the population at the instant, and that in a period of 40 years the population increased from 30,000 to 40,000. So पहला step आपको पता है कि the population, let the population at any given time be p. So generally हम population के लिए variable p use करते हैं. Okay? अगर कुछ और चीज होती है तो we'll take the variable accordingly. X भी use कर सकते हैं, volume में भी use कर सकते हैं. Okay? And if they've already given the variable, then you have to use that. Given time be p. So now we know that the rate of increase, so dp by dt is the rate of increase which is directly proportional to p. ये आपका first step आएगा. So when it is directly proportional, a constant of proportionality comes in picture which is kp, and then क्योंकि ये differential equation है तो हम p को एक साथ लाएंगे, this becomes k dt, and then we'll solve this differential equation. ये first kind of differential equation है, separation of variables जहाँ होते हैं. So this becomes log p is equal to kt plus c. ये एक base format मिल गया है हमें. Now we have to find out the value of k and c for the given information. Now initial stage पे when t is equal to 0, the original population is taken as 30,000. So p is given as 30,000. We'll put this value. So log 30,000 is equal to 0 plus c, and then we can see c is log 30,000. So now your equation forms as log p is equal to kt plus log 30,000. Now the second stage, which is the next station, that in a period of 40 years the population increased from 30 to 40. So this we are using for the variable k because still k is missing. So after 40 years when t is 40, आपका p क्या हो रहा है? That is 40,000. So when we use this, log 40,000 is equal to 40k plus log 30,000. Switch this log 30,000 to this side, तो आपको ये मिलेगा log 4 by 3, which is equal to 40k, and then you can write 1 by 40 log 4 by 3 is equal to k. But our work is not over here. We have found K, we have found C. Now we have to put it into the given equation. So equation हमने already यहाँ देखा हुआ था. Equation was log P is equal to KT plus C. इसमें ही put करने जा रही हूँ मैं इन values को. So when I'm putting the values over here, the final equation which I'm going to get is log P is equal to, because they have not given you the T and they have just told that find it for a particular time period. So log P is equal to, instead of K, I'm writing 1 by 40 log 4 by 3 into T, okay, plus log 30,000. Okay, आप question यहाँ पे भी छोड़ सकते हो, or you can switch over here. ये आ जाएगा log P upon 30,000. Okay, and this is log 4 by 3 to the power of T by 40, because log M by N का formula है आपका यहाँ पे, and then आप log को यहाँ पे replace कर सकते हो with the things. So when you replace the log, आपको वैल्यू मिल जाएगी P by 30,000 is equal to 4 by 3 to the power of T by 40, and to get any value population at the time T, P will be equal to 30,000 and then 4 by 3 to the power of 3 by 40. So this is how we can use these questions to calculate the estimated population after some time. It can also be used for rate of radioactive decay. It can also be used for rate of depreciation of a machine. But only thing when we are talking about growth or population growth, bacterial growth, आपका equation होगा dP by dP is directly proportional to P, and when we are talking about some depreciation or radioactive decay, it will become minus of that variable, and then you will be able to come to the answer in the same manner. So this was your last chapter of grade 12th Commerce Mathematics 1 ka, and in this manner, if you follow each and every video, I am sure you people will be able to come out with flying colors at the end of that. If there's any doubt, last video may I will come up with small tricks also. When I'm dealing the next chapter, I'll come up with the small tricks of solving the papers. So till then, please study hard and all the best to you people for your examinations. Bye-bye.